Let's find the slope of the line containing this pair of points. Now look how it's given. F of 2 is 5. This means when you put in a 2, you get out of 5. So that corresponds to this ordered pair, 2, 5. And then f of negative 2 is equal to 5 means when you put in negative 2, you get out 5. All right, so that corresponds to this ordered pair, negative 2 and 5. So before we just jump in using the slope formula, let's just see what this looks like. Here's a graph. If we, what does this point here say? If we go to the right 2, we'll go up 5. To the right 2, up 5, maybe it's like here. What does this point say? If we go to the left 2, we'll go up 5. So go to the left 2, up 5. So what kind of line do we get here? There's the origin. We're going to get a horizontal line. And horizontal lines, we know, have slope of 0. So we can do this one without any computation at all. Now in 12, we want to find the slope, if it exists, of this line here. Well, this line here, if we just graph that, there's only one variable, and it's x. So this line cuts through the x-axis at, tells us right here, at negative 5. So we know that if there's only one variable, you either get a horizontal line or a vertical line. If it's x equals something, that something is where the line crosses the axis. So we're going to get this line here. Now that's a vertical line, and vertical lines have undefined slope. Here in problem 13, we want to find the slope of this line. Now notice the form. The form is, all right, f of x, we can write that as a y. All right, this form is y equals mx, right, some number times x, and that multiplier of x is always the slope, plus b. So this number right here, m, that multiplier of x is the slope, and up here, for us, that is 1/3, so the slope here is 1/3. Now, what that means is, on a graph, it means this. If we're anywhere on the graph, if we go over 3, right, the bottom number is the horizontal change, the top number is the corresponding vertical change. We would go up 1, and the line would pass through those points there. Find the slope of this line right here. Now look at the form. We have y equals b plus mx. Now the multiplier of the x, the multiplier of x is always the slope. Now the multiplier of x up here is negative 4, right? Doesn't matter if it's written as, it could be written as mx plus b or b plus mx. It doesn't matter. Addition's commutative, but the multiplier of x is the slope. So the slope here is negative 4. So let's just claim that. The slope is, whoops, let's write it so it's readable. The slope is negative 4. Slope of this line, there's only one variable. Now remember, if there's only one variable, it's either a horizontal line or a vertical line. And how do you tell? Well, this says y equals. So this line crosses the y-axis. And where does it cross? It crosses at 0.2. All right, so maybe that would be 0.2. All right, so this is a horizontal line. And horizontal lines have slope 0. Well, we got a word problem here, a lot of words, but let's just take a little pieces at a time. Here's what we know. The number of visits to public libraries. All right, here's what we know. It increased from 1.3 billion in 1990. So right away, just do parts of it at a time. I know this. In 1990, the number of visits, 1.3. And then it says it increased to 1.6 billion in 1995. So in 1995, there was 1.6 billion. Now, these numbers are already in billions, so let's just write 1.3, 1.6. And now I have two ordered pairs. I can find the slope of that, of the line that passes through those. But we are asked to find the average rate of change. Now, the average rate of change, well, that's equal to the slope. And the slope, we have a formula for the slope, don't we? It goes like this. The second y minus the first y over the second x minus the first x. Now, as I look at my ordered pairs, if I just look left to right, this is the first x, that's the first y, the first x that I see, the first y that I see. This is the second x I see, that's the second y I see. So let's plug these values in and compute. So our slope is going to be, all right, second y minus first y. All right, second y minus first y. Now the second y is 1.6, first y is 1.3. So this is going to be 1.6 minus 1.3 over the second x minus the first x. And the second x is 1995, the first x is 1990. Well, we can do these. What are we going to get? The slope is equal to 1.6 minus 1.3 is like 16 minus 13. We're going to get 0.3 over 5. Now, if you want to do that on your calculator, that's fine. Just type in 0.3 divided by 5, and we're going to get 0.06, and that's billion. So the question is this. Now, I don't want to leave my answer like that. That's just a slope. What's the question? I'm going to answer the question. Find the average rate of change. Okay, so the average rate of change is, I'm going to write it as a sentence, and I'm going to say, I've got this slope, but that's not what we're asked for. We're not asked for the slope. We're using the slope to get the average rate of change. So I'm going to say, I answer the question. The question is, what's the average rate of change? So I'll answer it. The average rate of change between 1990 and 1995 is, now there's the 0.06, but what is it? It's billion visits per year. Right, now if you look back up here at the slope, if you write the slope as a fraction, which is really what it is, right? The slope is a fraction. The top number is the change in the output. Bottom number is the change in the input. If I write this as a fraction, 0.06 over 1, the top number is visits per year, and the bottom number, top number is the number of visits. This is the number of years. So in 1 year, we'll increase by 0.06 billion visits.